Hey everyone, let's take a look at an example problem utilizing vectors. We're going to add these vectors together and we're going to find a solution to this problem using a couple of different methods. All right, so here's a piston that's going back and forth as AD rotates around in a circle, and then the bar DP is going to push the piston and pull it back out. So this is going to go back and forth. But we're going to look at this simple configuration as we've got it set up. Okay, so from A to D, I'm going to mark that as vector RAD, right, because I'm going from point A to point D. And then from D to P, that's going to be RDP. And those two lengths are known, so we're just going to say that RAD is 50 millimeters and RDP is 125 millimeters. But what we're interested in is when the angle in here is 36.9 degrees, what's the length of RAP? How far is it from point A to point P, right? That's going to vary. That's going to vary as AD goes around in circles. Okay, so I'm interested in finding the length or the magnitude. This means the magnitude of vector RAP. Now, one of the things that's not specifically stated in this problem, but it's understood, is that from A to P is level. In other words, this is a fixed point in space. D is moving as the whole thing rotates, and then P is moving inside the cylinder, and so the piston's going back and forth, left and right, but it's horizontal. Okay, so this is considered to be my x-axis, if you will. All right, so we need to solve this problem. Well, the angles alpha and theta are unknown. Well, let me step back. So this triangle shows that RAD vector plus RDP vector equals RAP vector, right? So I add one vector to the other, and that gives us the third vector. Okay, so let me just specify that then. So AD vector plus RDP vector equals RAP vector. Okay, and so they add them together. We add this together, and we get a closed triangle. All right, so I need alpha and theta in order to get this solved. So there's a couple of different routes I can take. I know these two sides, and I know an angle not between those two sides. So to me, that says, hey, we want to use the law of sines. And so the law of sines says RAD, and I'm not going to put a vector sign over it because that means the magnitude, right? So RAP, absolute value, is the magnitude of RAP. I can also write that as RAP without the vector sign. That's understood to be the size of that vector, the magnitude of that vector. So RAD over the sine of theta equals RDP over the sine of 36.9 degrees. And 36.9 degrees, there should be more decimal places, but I'll leave it alone at that. That's a 3, 4, 5 triangle. Okay, that's why I chose that angle. Okay, so RAD, that's given as 50 millimeters. I don't know what theta is. And then RDP is given at 125 millimeters. And then the sine of 36.9, that's 345, so that's 3/5 of 0.6, okay? All right, so there's part of the law of sines. I can go one more, and I will in a minute, but I'm going to stop at that point. I need to find out what theta is. All right, so I bring that over, and I'm going to get 3/5 times 50 millimeters all over 125 millimeters equals the sine of theta. Okay, and then that's just, the millimeters go away, so that's just going to be 30 over 125 is the sine of that angle. And so if I solve for that theta, I get 13.88654. Okay, so I've got that angle, right? So now I know what theta is. And then I can use 36.9 plus 13, and I can solve for alpha. And if I do that, so if I take 36.9 and then 13 point, I'm just going to round that off to 89. There's the 7. So 50.79. So 130 come back. So 129.21 degrees equals alpha. So now I do know the angle between RAD and RDP. And I can use the law of cosines to find RAP. And I will, but let's do this first. I now know all of the angles, and so if I say, well, the sine of alpha, this would be RAP over the sine of alpha. And so I know all of this stuff over here. Sine of alpha is given, right? Alpha is given. And I can solve that for RAP. And if I do that, I get 161.654. No, 645. Yep, 645. And that's going to be in millimeters. And so now, what's RAP then? It's going to be 162 millimeters. Right? So I have 3 digits here. 500, 1, 2, 3. 500, 1, 2, 5. That's 3 digits. 369, 3 digits. And so my final answer can only be out to 3 digits. Now, if I need to use this number again later on, I'm going to use this one. Right? Anytime you use a number that you found in some calculations and you're going to use that number later, don't use the rounded off value. Use everything your calculator spits out. In fact, my calculator spit out more than that. But this is the rounded off value for the length from A to P at this point in time. Right, at this point. There's no physical object in here, so that's just the distance from the hinge on the cylinder to point A, which is the axis of rotation for AD. Okay? Okay, then we could use law of cosines, and we could use components. So I'm going to stop there, and we'll look at those 2 methods in the next video. All right, if you have any questions so far, please leave them in the comments below. Thank you.